The first chapter is about quality characteristics. It is divided into two characteristics, which is attribute and variable. For the attribute characteristics, we define it as seal condition and dead condition for the packaging. And for the variable, we define it as real volume of the product and brutto weight of the product.
Statistical process control are methodology used to measure and control quality in manufacturing processes. There are generally 7 tools of quality control. And in this case of Akisa Rosella drink, control charts are used to measure and control the process. The assessment relies on the real-time data gathered and calculation of control limit to define whether the process is in statistical control or out of statistical control. The control chart can be categorized into control chart for variable and control chart for attributes.
So for the next section is about the statistical process control, and it's basically divided into two big parts, which is the variable and attribute. One of the variable dealing with Rosella drink filling, so it assesses the height in each bottle, and the number of data gathered is 25 data with 4 subgroups, and you can see the data on the table above. Those data is processed into an X bar and R chart as shown in the next slide. From the chart, it can be seen that there is no point which located outside the range, and all of them are vary within the upper control limit and the lower control limit. Therefore, we can conclude that all samples are still in control. This condition could happen because the filling process is done manually by the worker without using measurement tool, or only by approximation. Even though there are gaps between one point with another, the value is relatively small, so we can tolerate it.
Another variable being assessed is the weight of Rosella drinks after filling process. This assessment uses control chart for variable with X-bar R chart. The data gathered with a total of 100 calculations consists of 25 samples for each observation. The weights are represented in grams. The X-bar R chart of the weight data are shown here. The R bar here is representing the process variability, as the range is the variability of the process. According to the Western electric rule, which derived from Shewhart's sensitizing rule, the process is considered to be in statistical control as no data falls beyond these control limits, and no consecutive data plots extreme to the rules. This applies for the sample range and sample mean, as there are no data plot falls beyond the control limit and no consecutive data plot extremes to the rules.
Besides variable, the attribute properties of Rosella drink also being assessed, and one of the attributes is the seal condition of bottle. The number of data that gathered is also 25 data with 4 subgroups, and the table in the slide shows the sum of 4 subgroups, so it's basically the final data. Okay, the next slide shows about the NP chart that processed from the attribute data before. In the graph, it can be seen that some points are coincide with the UCL or LCL line, but none of it that cross the limit. Therefore, we can still conclude that the sample is in control.
Other attributes being assessed is the condition of the bottle, whether it is dented or not. The dented bottle considered to be defect. The total of 25 data gathered with subgroup number of 4. The NP chart shows the number of non-conforming from each subgroup. Based on the graph, there are no data plot falls beyond the control limit, thus indicating that the process is in statistical control. But there are several data plots that falls exactly at the upper control limit. There could be an insignificant assignable counts that are needed to be examined along the process, because those data are in the farthest bound and could almost make the whole process considered to be out of control.
In this part, we would like to know if the process used in the making of Rosella drink is capable or not. The first one is weight variable. The data used is the same as the input of SPC. From this, we can see the process capability index or CP is 1. This indicates that the current process is capable. The next one is volume variable. The data used is also the same as the input of SPC. From this, we can see the process capability index or CP for volume variable is also 1. This indicates that the current process is also capable enough.
The analysis of variance, or ANOVA, is used to know whether all of the Tehrosella products have the same mean volumes when using 3 different methods in filling the bottles. So here, the factor is bottle filling methods, and it has 3 levels. The 3 different methods are using a jug and a funnel, and using a ladle and a funnel. All the methods are tested by taking 5 examples each, which is shown in the table. So here is the data recapitulation of Tehrosella volumes using different filling methods. We then determine the null and alternative hypothesis. The null hypothesis is that all means are the same, and the alternative hypothesis is that at least one of the means is different. The data is then used to analyze its variance by using the one-way ANOVA in Microsoft Excel. And here are the results of the analysis of variance. And let's see at the F ratio value here. The F statistic measures if the means of different samples are significantly different or not. The lower the F ratio, it means the more similar the sample means are. And the F is calculated by dividing between the SS between divided by the SS within. We then compare the F ratio with the F critical here. And if the F ratio is larger than the F critical value, we reject the null hypothesis. But in the ANOVA results here, we can see that the F is smaller than the F critical value. So we do not have sufficient evidence to reject the null hypothesis, and we can say that the different bottle filling methods do not have significantly effect on the volumes of the Tehrosella. And then we look at the p-value here, which is 0.2949. And the p-value is larger than the significance level. The significance level is 0.05. And this means that the differences between the means are not significantly different, and we do not have enough evidence to reject the null hypothesis. So we can conclude that the different bottle filling methods do not have significant effect on the volumes of Tehrosella products.
The next part is about quality assurance, in which it's a method used by the SME to assure their quality. Method used by this SME are final inspection, which is checking only for indentation and seal condition of the packaging, without measuring the volume or weight of the product. The last part is about the improvement. It can be drawn by analyzing several tools used in measuring the quality of this SME. The improvement that we propose are 1. Using measurement jug in filling the bottle, and 2. Make a standardization process. Thank you.